Historically, forest management practice in the United States was based on the European concept of a regulated forest developed in Germany and France. This meant that a forest was managed for continual existence across a landscape, but with optimum wood production. This was based on basic tree physiology, where younger trees tend to devote more of their photosynthetic sugar production into actual wood production. On this cross-section of this European spruce tree, we can see that the first 5 years of growth, the annual ring width, that's the wood deposited every year, is fairly wide. As the tree gets older, those ring widths become narrower and narrower. This is in part a proportion in that as the rings get wider, the same amount of wood production requires a narrower ring. That is, a larger diameter with a narrower ring produces the same amount of wood as a smaller diameter with a wide ring. However, it's been noted that especially for evergreen trees, such as pines, spruce, and fir trees, that once trees reach a certain age, typically around 100 to 120 years of age, that proportional wood production to diameter becomes much less. In other words, the tree is producing very marginal amounts of wood at older ages. This concept resulted in a maximum tree age of 120 years in the regulated forest concepts in Europe. Once a tree reached about 120 years of age, it wasn't producing enough wood to be economically efficient to keep it growing. And therefore, all forests were harvested by the time they reached 120 years of age and started over again as young forests to capitalize on this rapid juvenile growth phase. In order to apply the concept of a regulated forest to the forests of the northern Rockies, stands of trees that were old and no longer producing wood at an acceptable rate were harvested in order to replace them with younger trees that were growing at a faster rate. In order to do this under the concepts of sustainability and long-term productivity, landscapes were divided into patches with the long-term plan that any given landscape would consist of patches of different aged trees, anywhere from starting out at year 0 to 100 years of age when they would be reharvested. However, the look of a clear cut and the impacts of wholesale clear cutting across landscapes had its backlashes. Water quality, species habitat diversity, many of the things associated with the early wild landscapes of the northern Rockies and of North America were thought to be negatively impacted by such types of forest management. And instead, the uniqueness of old growth trees and a mixture of dense patches for wildlife habitat and water quality became incorporated and were questioned with regard to the role of forest management across the landscape. Wildlife was used as an indicator species, such as bull trout or grizzly bears. It was thought that regulated forests did not provide adequate habitat for such species biodiversity. The northern Rockies, of course, are unique in that they still, at the time of this ecological awakening, supported all of the original wildlife species that once existed here. Management practices such as intensive timber harvesting that at the time also required high road densities, a lot of soil disturbance, also resulted in sedimentation of streams, loss of visual aesthetics, and in some cases, losses of the function of that ecosystem. This resulted in what might be called the ecological revolution, where the value of forested landscapes were thought to be higher for natural processes, wildlife habitat, or ecosystem services, clean water, recreational sites, originally intact and functioning ecosystems, than pure wood production and intensive land management. The long-term result of this revolution was basically the shutting down of commercial timber harvesting off of federal lands, unless it's proven that such harvesting will have no negative ecological consequences. When considering that a forest is such a complex entity, proving that a forest management action will have no negative consequences has become almost an impossible task. With the recognition that intensive forest management seemed to be having negative consequences on the natural processes of the northern Rockies forest ecosystems, as well as other forested areas, an intensive study of how these forests functioned prior to forest management and logging was initiated. As we understood more about how disturbance played a role across these forest ecosystems, we also started to see a change in our climate, and with that, a change in fire behavior across these landscapes. Standard placing wildfires became more common and larger across the landscape. And as they burned across these landscapes, both natural and previously managed, certain other patterns started to emerge. One of them was what we call a clear-cut effect. That historic square harvest on the landscape that was seen as an eyesore suddenly became noticeable as the only place where tree regeneration survived in such landscape-level events. Examples were numerous. Here again is the Fridley Fire landscape, where a 20,000 acre black patch was created by the wildfire. That is, until it burned into privately owned forest where the landowner had previously conducted some small clear cuts across this landscape shown within these red circles. Even though this was a wall of flame that burned down across this landscape, these previous clear cuts were the only places where green trees survived this conflagration. And more importantly, the only place in a lodgepole pine dominated forest ecosystem where the fire killed all species other than lodgepole pine, which has the capacity to regenerate. These previous clear cuts are now refugia for Douglas fir and Engelmann spruce that are now seeding into the surrounding landscapes and thereby providing biodiversity back into this ecosystem, as well as forest cover for some of the wildlife that remain on this landscape that needed such forest cover. This effect can be seen even to a greater impact in northwestern Montana, where a large landscape level clear cutting had been instigated in order to combat the mountain pine beetle outbreak of the 1970s. This patchwork of clear cuts and old growth timber showed that when a fire does burn, it tends to burn through the old growth where the fuel accumulations were very high, but leave the former clear-cut patches intact, thereby burning a mosaic across the landscape instead of one big, large black patch. This may benefit wildlife because these green islands are refugia for wildlife and plant species. It has also been seen that landscapes that experience wildfires, particularly wildfires of unprecedented severity, are benefited by past management practices. In this case, half of this landscape had been harvested, leaving predominantly larch as a remaining tree on the left side of this picture, whereas on the right side of the picture was unmanaged forest. When fire burned across this landscape, it was standard placing in the high fuel conditions of the unmanaged forest and dropped to the ground as a surface fire in the managed forest, allowing for successful containment by fire crews. Thinning, where tree density is reduced to improve the vigor of remaining trees by giving them more soil water to work off, more space to grow in, was also shown as an effective tool in constraining the expansiveness and the severity of the new wildfire behavior we were seeing across the northern Rockies. The right side of this picture, separated by the road, the forest had been thinned. To the left, it had been left in its original condition. And although it burned across the road through the thinned area, the impacts of the wildfire was much less, leaving mostly live trees and acting as an understory fire versus the standard placing fire on the left. Although thinning benefits the trees in their resilience to fire, it also benefits fire suppression crews that might be trying to contain a fire and keep it out of communities. The other impacts of thinning in forest management are that areas that had been opened up tend to recover much faster. Here's an opening that was created in a ponderosa pine forest that burned as a standard placing fire. That opening had been colonized by native grasses, and native grasses are not killed by fires. Only the tops are burned off. So in the spring following this fire, those open areas are regenerated with native grasses that help slow down erosion and water movement off of these slopes. Such landscapes where there's a diversity of forest structure and species offer a more resilient landscape where trees can survive and the habitat that they provide for wildlife remains behind. As our climate changes and becomes warmer, it is becoming increasingly important to preserve some of the genetics of the tree species that are on the landscape. Forest management, such as done on this private ownership surrounded by national forest, resulted in a more open stand structure that, although it burned, kept the fire on the ground, leaving the old trees and the genetic resource intact on this landscape. The result is that these trees were able to successfully regenerate the landscape and acted as a seed source for the larger landscape, keeping the local genetics intact. Logging has progressed to a much greater science and still remains an art, where loggers have low impact equipment that has fewer impacts on wildlife. This herd of elk is actually attracted to the logging because they like to eat the lichens off of the trees that are dropped down. Past forest management, although not really mimicking natural processes by creating rectangular clear cuts rather than the irregular shapes that a mixed severity fire would create, have also shown their benefit by providing age class diversity and species diversity across a landscape. In this case, Douglas fir bark beetle that prefers to attack and colonize old Douglas fir trees and has done so successfully where those trees exist on the landscape are unable to impact the younger trees, thus creating a mosaic on this landscape that preserves the integrity of the forest. What could be done better, and what we know now, is not to create such rectangular shapes on a landscape, but rather to mimic the patches that a wildfire might create. Likewise, where mountain pine beetle has had devastating consequences across millions of acres of mature lodgepole pine, where past harvesting has simulated or emulated stand replacing fires, as in these clear cuts with the younger ponderosa pine trees, this landscape has much greater diversity, much greater wildlife habitat, and much more resilience to climate change because of the different species and the different age classes that have been promoted by these management activities. With the increased knowledge of how disturbance processes and forest function across the northern Rockies, as well as our greater understanding of climate variability and the real possibility that our climate might be in a warming and drying trend across the landscapes, the role of forest management has taken on a new perspective. With it comes the knowledge that the more diverse a landscape in species composition, forest structure, the more resilient that landscape may be in light of dramatic changes in precipitation and temperature and the role of disturbance processes. This can be shown by the historic impact of the square clear cuts on the landscape, where those clear cuts now are the only place where we have vigorous growing trees, and the unmanaged forest landscape has been killed largely by mountain pine beetle attack and is prone to large landscape level stand replacing fires. Such impacts are noticed across multiple species and multiple scales. Here, these old clear cuts that resulted in pine and Douglas fir regeneration have proven themselves resilient to the Douglas fir beetle outbreak that only attacked the old mature Douglas fir. And although the geometric shape of these clear cuts is not desirable these days, creating diversity across a landscape that mimics natural processes such as wildfire can help moderate and control the severity of natural processes that are enhanced by a warming climate. Managing for a diversity of age classes, even if it's the same species, creates tremendous resilience in the landscape. Mountain pine beetle, Douglas fir beetle all prefer large mature trees, and having regeneration patches helps keep some green trees and green forested patches on the landscape. In addition, the regeneration phase is where genetic selection occurs for the new climate. Of the millions of seeds landing on this harvest unit, only those seedlings that are best adapted to the new conditions will grow and survive into mature trees to once again produce seeds. Aside from clear cutting, there are multiple other forest management practices that can help forest landscapes become more resilient. Thinning, which decreases the water stress to the residual trees, has proven itself to be effective in reducing, not eliminating, but reducing the impacts of catastrophic landscape level pest outbreaks. In this case, spruce budworm, which has defoliated all of the Douglas fir in the denser stands, has not been able to be as successful in the thin stand because the trees are vigorous enough to produce various secondary defense mechanisms against defoliators such as spruce budworm. There also has to be some recognition that forested landscapes not only provide ecosystem services to the human population surrounding them, but they also provide an important economic resource to those communities. So is it possible to manage these natural forested landscapes in such a way that ecosystem integrity, ecosystem processes, forest diversity, and resilience are maintained while also delivering certain commodity products such as wood to the local communities and to the human economy? The forests we see across the magnificent landscape of the Northern Rockies is a legacy left to us by the combined series of historical events: wildfires, glaciers, climatic variability, Native American burning, cool wet periods, hot dry periods, and fire suppression. They represent a highly complex and unique conglomeration of natural processes and, at some level, human interference. As our climate moves into a warmer and drier phase, the real question that needs to be asked is, what is the role of human management across these landscapes? Is the management that we conduct going to harm these ecosystems and their adaptation to a new climate? Or are there things that we can do to increase their resilience, to perhaps moderate the effects of a major climatic change that historically may have erased a lot of this forest off the landscape with climate-driven wildfires of unprecedented magnitude? If we examine the landscape in this slide, which is a mosaic of species and age classes, only partially shown by the larch that has turned color this fall, larch being a species that requires some level of disturbance, either clear-cutting or fire, in order to regenerate, can management enhance the resilience of this forest to be able to allow it to better adapt to a changing climate? In this case, a series of management units was implemented across this landscape to make money for the landowners by producing lumber for the economy, but also to increase the diversity across this landscape. Incidentally, this management pattern on this landscape is based on the historic memory of tribal elders of the Confederate Salish Kootenai and Pend Oreille tribes. And management here is seen as a process to maintain and sustain the historic services that this landscape provided to indigenous people. Although wildfires can create a similar mosaic on the landscape, relying entirely on natural wildfires to create the most resilient forest landscape is a big gamble, especially with a changing climate. Pictured here is a mosaic similar to what the Salish Kootenai tribes are trying to create, only created by wildfires, though this type of fire mosaic is actually the minority of how wildfires burn today. Pictured here is a graphical representation of the temperatures across the Northern Rockies over the last century. The red line on the upper end of the graph represents the summer maximum temperatures, and the blue line represents the minimum temperatures. These temperature patterns are separated out by average spring, summer, fall, and winter temperatures. The black line shows the average change in temperature. And even though there are tremendous fluctuations in these temperatures, one can see that both summer and winter temperatures have slowly increased. This also means that the climate we are approaching is more analogous to the first 8,000 years of the last 10,000 years, where temperatures were warmer and precipitation was somewhat less. If you recall the historical pollen analysis from the lakes, forest expansiveness during these warmer, drier times was much less than it is today. Water availability is of primary importance to how forests function across the Northern Rockies. This chart is a graphical representation of data collected across the past 2 decades of average water flow in major watersheds across the Northern Rockies. Red arrows indicate lower than average water flows. The size of the arrow indicates the magnitude of the departure from the average. Larger red arrows mean much lesser water flows. Blue arrows indicate higher than average stream discharges. What stream discharges represent is overall water availability across the landscape. So this graph clearly indicates that much of the northern Rockies has been under a significant drought across the past 2 decades. What the graph also indicates is what's happening in the forests and the higher elevations and forested landscapes flows downstream and impacts the end users of these watersheds. That means the towns and the communities that rely on water flow from these streams, as well as the wildlife and the fish that require water flow. Does forest management impact water availability? I've already shown that thinning reduces overall water use by trees and can increase tree vigor by increasing the amount of water available in the soil to an individual tree. What has also been shown through research is that thinning decreases the amount of snow held up in the canopies of trees that evaporates right back in the air versus being deposited in the soil and flowing downstream. Here's an example of looking from a dense forest into an opening in late spring, and you can see where the snow remains. Likewise, other forest types show the same phenomenon where patches and gaps and openings in thinned areas retain deeper snowpacks later in the spring that provide more water to the landscape and to the streams. Forest management that works within the natural realm of past disturbance processes across these landscapes, thereby thinning patches of overly dense trees or creating openings in overly dense forests, have benefits that go beyond increasing the resilience and maintaining the genetic diversity of forests across the landscape. These same practices may also increase water flows into the main watersheds and streams that people depend on. The forests across the northern Rockies that we see today are the result of the last 10,000 years of complex ecological processes, ranging from climatic variability that for the first 8,000 years prevented forests from expanding to their current range, to insects and diseases that periodically killed off vast numbers of individual tree species, selecting for those that have a greater genetic resilience, to wildfires that varied in their severity and expansiveness, creating a patchy mosaic of tree species, both fire-resistant and fire-intolerant across these landscapes. Historically, native peoples played an important role in how these forests developed and evolved by their use of fire in keeping certain areas open for travel, in regenerating huckleberries and other important native forbs and shrub species. The last century has seen dramatic changes across these forests, both from the results of human interference as well as profound climatic influences, such as the cool wet period from the 1940s until the 1980s. Managing these forests for multiple uses and ecosystem services while maintaining the integrity of these ecosystem processes is a daunting and extremely complicated task. However, science and the knowledge we have today allows us to manage within these natural processes in such a way that we benefit these forests rather than adversely impact them. Our climate is predicted to continue to warm and dry, resulting in greater propensity for catastrophic and uncharacteristic wildfires across these landscapes. Such wildfires in the wrong places can reduce the natural diversity and genetic heritage that was created over the last 10,000 years. Management practices that moderate these types of climatically driven and weather-driven extreme events will overall benefit these ecosystems and at the same time benefit the communities that harvest the materials off of these forests, that can impact water flows, that can impact genetic diversity across these landscapes. The knowledge of how to do this in a thoughtful and careful manner exists. The next step is to allow those trained to implement forest management practices that benefit both humans and natural processes. Of specific concern for the forests of the northern Rockies are greater weather extremes brought by a changing climate. With those come shorter return between standard placing events and the expansion of standard placing fires into forest ecosystems that historically did not experience these types of events. Greater insect and disease outbreaks. As dense forests become stressed from lack of water, they also become less able to defend themselves from pests and pathogens, creating outbreaks of larger magnitude, which in turn create fuels of larger magnitude and help exacerbate the severe fire effects. Invasive species, including noxious weeds and exotic pests that can attack our trees and our forests and impact the integrity of these ecosystems. Periods of drought that result in periods with low stream flow, loss of fisheries, water quantity and quality, which also impact endangered species, such as bull trout. Overall, a loss of forest cover and productivity. As water becomes limited and fire becomes more frequent, the expansiveness of forests and the occurrence of trees across landscapes will become more limited. Regeneration of tree species will become more limited as spring droughts kill newly germinated tree seedlings. How we respond to these predicted changes and the current changes we're seeing is something that society has to decide upon. We may practice something called human-assisted adaptation, where our management practices, whether creating more diversity on a landscape, less stress by thinning trees, assistance with regeneration in areas where natural seed sources are lacking, may allow us to help species adapt to changes in our climate and maintain forest ecosystems in some capacity across these large landscapes and all of the services that these forest ecosystems provide for us, including clean water, wildlife habitat, recreational opportunities, and wood, a raw material that can be utilized for multiple things from homes to bioenergy and petroleum substitute fuels, providing both human society with the resources they need from these landscapes, as well as helping the landscapes themselves adapt to changing climate and a greater frequency of disturbance events.